So we've been talking about exponential and logarithmic functions, and we have done some applications, but today's lesson is focused on using those functions with compound interest. So keep in mind what compound interest is. This is actually part of your assignment. I would like you to look up the meaning of compound interest. Okay, the first formulas that I'm going to give to you, you have to understand the difference between these and what would be on the back side of the notes. The first formulas are about a set amount of money that, for example, you're putting into savings and not touching. Okay, so say that you got an amount, so many dollars for graduation, and you are not going to touch it until after you graduate from college. All right, so let's take a look at these formulas. And if you take a look at the first one, this is a formula that the interest is compounded annually. Now, this should look familiar to you because doesn't that look like the exponential growth formula that we have? All right, now the next one is that it's compounded certain times of the year. So when we have a rate, when a bank gives you a rate or a credit card or whatever, that rate is an annual percentage rate. So if we're talking about a deposit, let's say this is a savings account, the rate that the bank gives you, if it's compounded so many times a year, you divide by that many times. Now, this is always raised to the time. So if, let's say it's for 5 years compounded 6 times a year, then that's going to be 72. So this is about time, how many times it is compounded. You just have to make sure that your rates correspond, the labels correspond with the exponent. Okay, and then we have a formula where it is compounded continuously, PERT. All right, so P for all of these, of course, stands for the amount that you're putting into savings, or like a CD, a certificate of deposit. All right, R, of course, stands for the annual percentage rate, and T or N stand for the amount of time in years. Okay, so if you need to stop to read these before I start explaining them, so you may want to stop, start, stop, start. All right, so the first problem is about putting in $1,500, let's say, into a bank account, and you're not going to touch it for 6 years, and it's going to earn an interest rate of 7%. So $1,500 is my amount. I'm going to earn 7%. That 1 is in there because that 1 means that's 100% of $1,500 plus the 7%, and for 6 years. So we would have 1 and 700ths to the 6th power, and times 1,500, that would be $2,251.10. At any time, I would encourage you to stop this and put it in your calculator, because sometimes the formulas look easy, but sometimes we just have to practice putting this in our calculator. Okay, so example 2. So again, if you need to stop this and read, and then come back. So we are, I don't know, let's say that I won the lottery, and not big lottery, but a lottery, and I got $25,300. Not that I'm encouraging gambling. And that this is compounded monthly, and I'm earning 4.5% in interest. So of course we always change our interest to a decimal, and earning 4.5%, that's compounded monthly. So I take that and divide it by 12, because remember, interest rates are given over a year. That's why you divide that by 12. This stands for how many times it will be compounded. So it's going to be compounded monthly, and I'm going to use self-control and not touch that for 25 years. Maybe that's something I'm putting towards retirement. And so putting that in my calculator, I get $77,765.69. Okay, so the next question asked, if I want to double my money, how long will I have to keep it in the bank if I'm earning 9% interest? Now, 9% interest is really high interest. So right now, currently, interest rates are really low. That's bad if you have investments, but that's good if you have loans, car loans, house loans, etc. Okay, so I'm going to have to solve for t. So here t is an exponent, so that's probably going to tell you we're going to be using a log. All right, so first of all, I always isolate my expression that has the variable, so I'm going to divide by 8,000. Now I'm going to log both sides and use my power rule and bring the 12t out front. I have to solve for t, so I'm going to divide by the log of this quantity, and then finally I'm going to divide by 12. So if I were you, I would break this apart, take this one step at a time, take the log of 2, divide by this quantity, and then finally divide by 12. So how long would it take me to double my money at this interest rate? Again, that interest rate is high, so it will not take as long as it would as if the interest rate was low. I got 7.73 years. Now, that's fine, but let's face it, we talk about years in terms of years and months. So we know it's going to be 7 years, so do you remember what I would do? 0.73 years. I would take that times 12 because that's the number of months in a year, and I would get about 7 years and 9 months. So yeah, I would like you to answer that question like that. Okay, now let's take a look at example 4. So example 4, it is asking, what does the rate need to be if I need this 22,000 to grow to 36,500? Okay, this is compounded daily. So my rate's going to be divided by 365, and I'm going to take, it's over 5 years is what I'm wanting to put it in and not touch it, times 365. So now I have to solve for R. Now keep in mind that there is not an unknown exponent, so I'm not going to be using a log. So I have to isolate R. So first of all, I took 365 times 5 and cleaned that up and got 1825. So I have to get R by itself. So the first thing I'm going to do is divide by 22,000. I didn't simplify that. I just showed you the steps. Now, take a look. I have to get to R, but isn't this raised to the 18/25th power? Okay, I have to work my way from the outside to the inside to get to R. So how am I going to undo the 18/25th power? Well, think about this. If this were raised to the 3rd power, wouldn't you cube root it? All right, so that means to undo the 18/25th power, I'm going to multiply or raise both sides to the 1 over 18/25th power. Remember, a cube root would undo a power to the 3rd power. All right, and then finally, I'm going to subtract 1 and then multiply by 365. So this expression to the 1 over 18/25th power minus 1 times 365. Now, of course, I get a decimal because this is a rate, and I would move my decimal point 2 places, and that would be 10.13%. Again, that is an amazing rate, but you would not, for today, you would not find anything at that rate, unless you have maybe some good investments in the market. Okay, the last example in the notes, I did not say, that was an error on my part, that it is compounded continuously. So this formula is a special formula that is describing interest compounded continuously. So as I mentioned when we introduced E or reviewed what E is found in different formulas with business and exponential and logarithmic functions. Okay, so I want to know how long will it take for this amount to basically double. If I have 12,500, if I wanted to double, I wanted to turn into 25,000. Again, it's at 9%, which is an amazing rate. Okay, so I'm going to divide by 12,500 because I always want to isolate the term that has the unknown. Now, since I have a base of E, I'm going to natural log both sides. And natural log, I'm using the log powers, natural log of E is 1. So I'll end up with the natural log of 2 divided by 9/100, which is about 7.7 years. Or if you take 7 times 12, you get 7 years and about 8.5 months. Okay, I'm going to stop this part 1 of the video, and then I will continue on the other side of the notes, and that is really the more practical formulas that deal with if you make investments and the amount is constantly changing, or even sadly for most of us, about loan payments, a house payment, a credit card payment, a car payment, school loan payment. All right, just to let you know, on a test or a quiz, you will not be asked to know these formulas, but you will have to know how to use them and where to use them.